Math 100, lab number 7. We're going to talk about functions and relations. And a function is a relation whose the x values don't repeat. So if you want to function properly, you don't repeat your x's. So to be a function, you can't repeat the x values. If we're looking at a graph, then the function needs to pass the vertical line test, meaning that any vertical line placed on the graph can only touch the graph in one place. If it touches it in more than one place, then it fails the vertical line test and is thus not a function. Okay. With functions, we're going to talk about their domains, which are the x values that would be moving left to right on a graph. The range or y values moving up and down on the graph. So we're going to look at a few examples of those. The first one is a relation in the form of a set of ordered pairs. So we have the ordered pair 1, 9, 3, 7, and 3, -4. The first question I want to answer is this a function? This is not a function because we have repeated x values. So the answer to that is no. But we still can determine the domain. The domain are the x values that are listed here. The x values are 1 and 3. And then the y values that would make up the range are -4, 7, and 9. Okay, let's look at another example. Here we have a relation listed as a set of ordered pairs. We want to determine, is this a function? So we look at the x values. We have 0, 3, 4, and 8. Those would be the values in the domain. None of them repeat, so that would mean this is a yes to, is this a function? The range would be the y values that are listed here. We do have some repeats on the y values, but that does not affect whether or not the relation is a function. So the range would be 5, 6, and 7. Here we have an equation, y equals x squared minus 7x plus 5. And we want to know, is this a function? Some general knowledge about the x squared graphs. With just an x being squared, it's a parabola shape, and those are typically functions. But we can look at the graph and determine with a vertical line test what that would be. So I'm going to go to y equals and type in x squared plus 7x. Oh, it's minus 7x. Let's go back and change that. And then it was plus 5. And we hit graph. And there we have that graph. We can see that no matter where I place a vertical line on that graph, that it would pass the vertical line test. So this is yes, it is a function. The domain for the squaring function is from negative infinity to positive infinity. It is for this function as well. The range, when we look at our graph there, we can see that this range is fairly close to -1, 2, 3, 4, 5, 6, 7, 8. Between -7 and -8, as far as that where that lowest point on the graph is. The things we'll learn later on go from there. So we're going to say it's from a -7.5 to infinity since it opens upward. That'd be a good estimate for that graph's or range. Let's look at function value. Well, here we have a function f of x is equal to 2x squared minus 3x plus 5, and they ask us to find f of 6. To find f of 6, you take 6 and replace the x values with 6. So it's going to be 2 times 36 minus 18 plus 5. 72 minus 18 plus 5. 77 minus 18. 67 minus 8 is 59, I believe. Check that with the calculator. 72 minus 18 plus 5. 59 is correct. And their value. Choose the same function and find f of -2. Again, replace x's, this time with -2. And work that out. So that's going to give us 4 times 2 is 8, plus 6 plus 5. We'll use arithmetic there. 14 plus 5 is that. Next example. It's function value again, but a little bit more difficult problem in the fact that we're plugging in variables instead of numbers. So we're going to replace x with a plus b. And then the only thing we can do is distribute 3 to both of those to make it look a little bit more like we've done something. And we've got the function value there, not a specific number. On lab 7, if you would omit numbers 4 and 7, they will not count against you on that lab.